All right, you guys, we are on the Chapter 7A review, and this is going to be working out the odds. Number 1 says a square park has a diagonal walkway from one corner to another. If the walkway is about 25 yards long, what is the approximate length of each side of the park? So the first thing I want to do is draw a picture. We've got a diagonal walkway that is 25 yards. And I'm looking for how long this side of the park is. There's two ways that you can solve this. One way is you could use the Pythagorean theorem, x squared plus x squared equals 25 squared. But because we've been practicing special rights this unit, that's what I'm going to use. I know that this square split into two equal pieces makes a 45, 45, 90. So from there, just like we do in class, I'm going to redraw the picture, label what I know, and then label my magic numbers. You will get the special formulas chart for your test, where you'll see that a 45, 45, 90 has a magic numbers of 1, 1, radical 2. I've got here and here are 45s. So from there, we divide in and multiply out. So I'm going to divide by radical 2. I know that 25 divided by radical 2 has to be multiplied by radical 2 over himself in order to get 25 radical 2 over 2. From there, I can simplify that. It'd be a decimal. But notice my answers are all here, and it's asking for the approximately. It's not asking for the simplest radical form, so what I can do is just put that in my calculator as 25 radical 2, and I'm going to hit enter to get 35.355. Then I'm going to divide all of that by 2. And I get 17.67766. So which one would approximately be the length of that side? That'll be 18 yards. Let's try number 3. A 16-foot ladder rests against a house so that its base is 4 feet from the house. Approximately, how high up the house does the ladder reach? Round your answer to the nearest tenth. Notice I don't have to keep it in simplest radical again, which is really nice. I'm looking for how high up on the house does the ladder reach. So that height would be right there. It tells me that it's a 16-foot ladder. So that 16 feet would be where the ladder is. And it's resting 4 feet from the base of the house. So when I have two sides of a right triangle, and I'm looking for the third, it's always Pythagorean theorem. I know that across from the right angle is your C, so I can put x squared plus 4 squared equals 16 squared. X squared plus 16 equals 16 squared is 256. Subtract 16 on both sides, and you get x squared equals 240. From there, you want to square root both sides. So x equals the square root of 240. I could leave my answer in simplest radical, but I don't have to because it asked me to round to the nearest tenth. So I put that in my calculator as the square root of 240. Enter. Rounded to the nearest tenth is right here. So I look right next door. That 9 tells the 4 to go up to a 5. So x equals 15.5 feet. Because all of that has been in feet. Moving on to page 2. Can you make a triangle with the following three lengths? If so, classify it as right, acute, or obtuse. So what we know is that the two smaller sides have to be greater than the third. Then we'll plug it into the Pythagorean theorem to see what kind of triangle it is. So number 9, is 5 plus 4 greater than 9? No, it's equal to. So this guy's a no. Number 11, is 8 plus 10 greater than 11? Yes. So I plug it into the Pythagorean theorem. 8 squared plus 10 squared is something compared to 11 squared. And I see which one's greater, which one's less than, which one's equal to. We've got 8 squared is 64, 10 squared is 100, something compared to 121. So you get 164 is something compared to 121, and it's greater than. So look at that c squared. If c squared is greater, then it's obtuse. If c squared is less than, it's acute. Number 13, I'm asked to find the indicated measures. So it asks for area. And what I know about area is a triangle is base times height divided by 2. So base is going to be 10 times 7. It's the height divided by 2. We actually don't need this 8 right here. We don't care about him. It's just there to trick us. So 70 divided by 2 is 35, and this is meters squared. Similar on number 15, but we're working backwards. They've given us the area is 126, and I know that equals base times height divided by 2. The first thing I'm going to do is just go ahead and multiply both sides by 2 to get this 2 out of the denominator. 126 times 2 is 252. That equals 14x. Then we divide by 14 on both sides. X equals 18. And that's in meters. Number 17 is solving for that missing side, and I know whenever I have two sides of a right triangle and I'm looking for the third, I have to use Pythagorean theorem. I locate the C. It's right across from the right angle. So x squared plus 6 squared equals 8 squared. X squared plus 36 equals 64. Subtract 36 on both sides. X squared equals, what is that? 64 minus 36, 28. From there, to get the x by himself, we go ahead and square root both sides. Let's go ahead and keep this in simplest radical form. When you square root the x squared, it cancels and you're just left with the x. The square root of 28 we can break down into 2 times 14. And then 14 breaks down into 2 times 7. So these guys get to break out of jail. 7 is stuck in jail. There's no units, so I can leave my answer like that. That's it for page 1 and 2 of chapter 7 test review.